Hello everyone, I would like to today discuss about how to use SmartISM for ISM for Interpretive Structural Modeling in just one click. Okay, so we have a software here, or SmartISM, which can be used to model the whole structure. Okay, so let's take an example here, and this we have used this software in on paper to model the cloud migration. Okay, we call it sustainable cloud migration, and the reference of the paper is given here. And the factors to model we had derived through 299 research articles using keyword analysis, and we drive 10 factors in there. So those factors are listed here, like virtualization, service orientation, data multi-utilization, dynamic allocation, mobile support, performance security, application, and migration. So these factors happen to be the most frequent or factor. With some analysis we did it. So now we want to establish, we wanted to establish a relationship. So the first step in ISM is to have structural self-interaction metrics, wherein we define the relationship between the two variables, with one of the relationship like the first is going to influence the other, or the second one influencing the first, or mutual um, influencing each other with X, and O when there is no relationship. I'm trying to move fast, so some for basic understanding you can read in the supplied references. Okay, then let's move on to this software. Okay, SmartISM. Okay, so let me share the screen for that. Okay, so we have this screen here, which is like showing number of we have to enter number of variables which are there, and names of the variables. And if we want to have the variables in the same order as in row in the columns, then we choose this option. Otherwise, if in reverse order, then we don't select it. By default, the column names will be in the reverse order, which is generally happens. So let's enter our variables into the um, model here in the website. So we have these variables, for example. Let's copy and paste here, and 10 variables are there. So we don't select this because generally we prefer to have in reverse order. Okay, so we generate now this matrix, which is SSIM matrix, and we have to define here the relationships. So for this relationship, there are various techniques there. You have to take the input from the decision makers. So various approaches are there for that. Anyway, we have already done that through a panel of experts. So I'm going to enter their inputs here. Okay, so these are the inputs here. So okay, fine. And for the second comparison, the second column, we had something like this. So we enter all these, and this is, as you can see here, is the most important step. Okay, next column we have this relationship, like this one here. um, okay, and then next column we had all V's, and next column we had two V's and one A, and after that we have XV, XV, O, and A, and in the next column we have X, V and A, and the last VV, and second last VV, and the last one V. Now we have all the relationships. Let me just make sure they are correct. A, VV, XVA, XVOA, and VVA, VV, all these, and then VVA, VO, VA, and then VO, V, and OO, V, VA, and fine. So now just click one on this calculate ISM results, and with just one click we'll get all the results here. You can see here we have the SSIM, which is the same as mentioned in the paper, and then we have reachability metrics, which is driven from SSIM, final reachability metrics, which includes transitivity, and from this FRM we generate micmac diagram, which is very neatly drawn in here. And then after that we have level partitioning from final reachability matrix. We assign the levels, and on the right side this is the first. On the left we have the final levels, but if you want to see the iterations, in each iteration you can go on, like click on 2, 3, 4 to see all the iterations. In 4 iterations we had this. Then we have conical matrix, which is sorted form of level by sorted form of FRM. And then we have digraph, you can see here, automatically drawn. And we had proposed new concept here in our paper, reduced conical matrix to remove the a lot of links here to make it cleaner model, and with labels in here. So we have this model, and finally, and we need to draw this model using some basically some graphic software. Okay, so let's go back and see. Let's go in our um, final model, how it has been drawn. So this is how this was drawn, the final model which we have seen here. Okay, so this is very useful software which can help you in drawing, developing ISM models with much ease. Thanks for watching the video, and hope it will be useful for you.